Properties of exponents. Now the real goal in this section or in this unit is to find the properties and understand properties of logarithms. But to understand the properties of logarithms, I believe we really need to understand the properties of exponents first. Now, we'll see why, not in this video, but in the next video or two. So for here, let's just talk about the properties of exponents. Let's say we multiply two things with the same base. So in this case, x is my base. And then each of these x's is raised to some sort of power. Here I'm calling them m and n. Now, what can I do with the exponents? Well, my claim is that if these two things that we're multiplying have the same base, then I can simply add the exponents. Now, why is that? I'm not going to prove it to you, but I'm going to try to convince you with a simple example. Because I think a lot of times we learn properties and we don't know why. We just try to memorize things and we don't realize that the understanding is actually pretty simple. Let's look at x squared times x cubed. What does that equal? Well, anything squared means the thing times itself. That's what x squared really means. It's a shorthand for x times x. And x cubed means it's x times x times x. Like that. Now, what does this equal? Well, we have x multiplied 5 times, or 5x's multiplied. And that gives us x to the 5th. Well, I don't want to do this, writing it out every single time. I just want to understand that there's a shortcut. I see that 2 plus 3 equals 5. Does that work always? The answer is yes. Let's just do one more. What if we did x to the 4th times x to the 5th? Well, let's be a bit of writing, but I have x times x times x times x. That's x to the 4th. And then x times x times x times x times x 5 times. That's x to the 5th. And if I put it all together, I have 9 of those, right? X to the 9th. What was the shortcut? I could have simply added the exponents. So the understanding is really simple. And if you ever forget the properties, you can just do a simple example and see what happens. Well, how about if we divide two things with the same base? What is the shortcut for this? Let's do this one through example. What if we had x to the 5th over x squared? And let's write it out longhand. X times x times x times x times x all over x times x. We see that things cancel. Those can cancel. These can cancel. And we're left with what? We're left with x times x times x, or x cubed. So what's the shortcut when we divide two things with the same base? And the shortcut is we can subtract the exponents. Okay. What if we had it upside down? What if we had x squared over x to the 5th? Let's write this out longhand. Get all the x's that we need. And now we can start canceling. X over x. Now be careful. X over x is 1. It's not 0. It doesn't disappear. It's 1. assuming x doesn't equal 0. And then I can cancel out another x, and I'll put a 1 there. And I have 1 over x cubed. But this property still holds, meaning I could have done x to the 2 minus 5. Dividing with the same base, we subtract exponents, which is x to the negative 3. This is why negative exponents flip things over. Negative exponents do not make things negative. Let's take a look at another property. Let's do x to the m to the, I'll call it p this time, to the p power. So a power to a power. What is the shortcut for this? I will do this one again through example. What if we have x squared all cubed? Okay, well, x squared means x times x. Something cubed means we have to do that 3 times. So x times x, x times x, x times x. And that gives us x to the 6th. So what is the shortcut here? Well, power to a power, we multiply the powers. One other quick property I want to talk about, that anything to the 0 power is 1. So what if we have complicated looking examples? We'll do, say, x cubed, and I'll throw in another letter, b squared, and I'll put this all to the 4th power. And let's divide this by x to the negative 2 times b to the negative 1. What does this simplify down to? Now, all complicated problems are a series of simple steps. So when something looks just too difficult to do, because there's so much going on, quit trying to solve it all and just do one piece. For example, let's look at the numerator only. Notice that I have powers to a power. I have x cubed to the 4th. Well, I know power to the power, we multiply the powers. B is a different base, so I just keep it separate. So I have b, right? I have b squared to the 4th, power to the power, you multiply the powers. How about on the bottom now? Don't worry about what I've just done, just look at the denominator. Similarly, I have things that are multiplied, but then I have powers to a power. So I have x to the negative 2 to the negative 1. Power to the power, we multiply powers, so I have x squared. And then I have b, really to the 1st, to the negative 1. Power to the power, multiply powers. So I have b to the negative 1. Well, what can I do now? There are a lot of different things I can do. One thing I notice is that x's go with x's, b's go with b's. I don't need to mix and match them. I can do each one separately. So I could think of it like this, like x to the 12th over x squared, and then times b to the 8th over b to the negative 1. And let's just handle the x's for now. Now I have division, same base, which means we subtract the exponents. Giving us x to the 10th times b to the 8th over b to the negative 1. I could subtract exponents here, but I'm going to practice negative exponents just to remind you what we could do. So I have x to the 10th times b to the 8th, And remember that a negative exponent will flip things. So since I have a negative exponent in the denominator, I'm now going to have a positive exponent in the numerator. So b to the first. And now I can put my b's together. When I multiply two things with the same base, we add the exponents.